Well, hello everyone. So I'm only here alone right now, but what I'm doing is I'm screen sharing the Eyes on NASA's Eyes on, um, and showing the simulation of the Juno, the Juno spacecraft. So I've been following this since the insertion of the orbital insertion, July 4th, and I thought I just might, for the heck of it, you know, show you where it's at right now. So let me actually maximize the screen. Actually, let me get there first. Let me just maximize the screen. And this is the simulator. Again, this is, yes, obviously it's a simulation um, of the Juno spacecraft. The solar wingspan, so to speak, is 66 feet-ish in diameter. So we're going to go to the simulator, and what we're doing here is we're following the mission. The orbital insertion was July 4th. It has begun its orbit. That is, the orbital insertion states that they did the maneuver to insert it into orbit. So basically, it's on its first orbit. So it's not actually completed its first orbit yet. So I'm going to show you a few things. I'm going to show you its projected, future orbits and things like that. But I'm going to show you sort of what's going on. And this is, again, a simulation. You are able to get this software. It's free. It's Eyes on NASA, Eyes on the solar system software. And when you install it, you'll see the button that says the Juno mission. So let's start with, let me see if I can do this right. Okay, so I'm going to go ahead and go with the Juno mission. And we're going to show you the Juno trajectories. So essentially, the idea is that, as you can see, like it's kind of like, I don't know if any of you know about the old toy spirograph. The idea is to put Juno in an orbit of a polar orbit, and it's going to swing very close and then swing way out and then swing very close and then swing way out. As you can see by this graphic, it's going to sooner or later cover the entire surface of Jupiter, right? What I could do now is show you what it is now. So I'm going to pull this aside. In other words, it came out. If you can see the mouse button, it swung into Jupiter and it's on its way on its first orbit. So it hasn't completed its first orbit yet. The Jupiter orbital insertion, JOI as they called it, the video that I've shared from NASA JPL. They made a trailer sort of trying to get people excited about this whole thing. This essentially is, let me see if I can zoom in a little bit. This is essentially what they did. They did the maneuver to insert the Juno spacecraft into orbit. So it came around. If you can see this faint line, I'm hoping that you can see my mouse button, my mouse arrow. So it swung around. They did the maneuver where it inserted itself into the orbit of Jupiter on a polar axis. And this is where Juno is now. That is, let me see if I can swing this. I'm sorry if I'm not controlling this very well. Let me see if I can zoom out. Okay, there it is. All right, so as you can see, it's not even halfway around. So it inserted itself into orbit, and it's swinging back around. Okay. Um, it's a 50, I think 53 days, 50 something days orbit. So obviously we're not nowhere near that 50 days. But this is a simulation, a software that you can get for yourself. But and this is real time, as you can see on the top of the screen here. It says real time. I click the now button. This is essentially a graphic to show you where Juno is in reference to Jupiter. And I'm swinging it around. You can drag it like I'm doing now. I'm dragging it around. Okay. So if I were to click on the Juno spacecraft itself, I can zoom in. I can zoom in. There we go. And so this is the spacecraft itself. As you can see, the solar panels, the new technology of solar panels allowed NASA to create a spacecraft that was actually able to use solar panels all the way out by Jupiter. The amount of light Jupiter receives from the sun is like 25% less than what we receive here. So it was difficult to do that. But the new technology in solar panels, NASA decided to try and do this, and they did it. So as you can see, the Juno orbital insertion process actually turned Juno away from the sun and then turned it back around to the sun. But as you can see, this is a real-time simulation. So there's the sun. As you can see, there's the sun right there. As you can see, Juno is actually pointed towards the sun. Obviously, for the reason that it needs to absorb the light for the solar panels. But during the Jupiter orbital insertion process, it had turned away from the sun. If you were following my Hangout at the time, you would have been able to see that. If you have this software, if you, again, just Google NASA Eyes, and you'll be able to get the software, you will be able to actually see the whole thing all over again. For example, the mission events. Okay, you can click on that, and you can go to the Jupiter orbital insertion, and you can see that in sped up time, and you can actually slow this down. You can actually just, you can watch this whole thing over again. So again, this is obviously a simulation. The actual pictures will be coming from NASA within the next couple of months or so. There has been the cameras actually were off during this Jupiter, during the orbital insertion. So you're not going to be able to see any actual pictures of the event. This is, again, a real-time simulation. So what does a real-time simulation mean? So a real-time simulation is this. Every time you start up NASA Eyes, you'll see a flash on your screen that says checking for updates. So what they're checking for is new data and actual data that's coming from NASA that says where the spacecraft supposedly is and all that stuff. And they feed that into the simulator so that what you're seeing in the simulation is theoretically real time. Okay, so as you can see, the top of the screen says replay. I'm replaying the events that happened already. So when I go to let me see, mission phases. And when I go to this particular point, I can click on the now button at the bottom of the screen. Okay, and it's going to show me a simulation of what is actually happening right now, where Juno is right now. Okay, and if I click on, let me see, where is that now? I'm sorry. You can view from above Jupiter. That's the view from above Jupiter. All right. So again, I'll make sure that's the now button. Okay, so you can see the clock is actually July 16, 2016 at this time, and that's the actual now time. So you can hold your mouse button down, and you can drag the view. Okay, so this is again a simulation, but it is using the data that they currently have as to where Juno actually is. So you can actually, let me zoom out. Okay, so there it is. So you can see where it actually is in reference to the planet Jupiter and etc. I mean, if I swung around enough, I can find the sun, and I can point to the sun and say there it is. So you can actually get a picture in your head of exactly what's going on. And again, it is in fact a simulation. So within several months, we will be seeing some pictures. NASA will be forthcoming with their information. So I can't stress enough how beautiful this software is. The fact that it's free. NASA wants everybody to see this. NASA wants every. Um, I can probably. Oh, by the way, there's other information. The distance from Jupiter is up here. The orbital speed, and you'll see the speed changing. Um, this NASA Eyes software also has not eyes on Earth, eyes on the solar system, eyes on exoplanets, and it's a fun thing to explore. Um, and then there's like 3 projects on the bottom. Juno, I think, not Cassini. Is it Cassini there? I forget. Any case, there's like 3 other spacecrafts that you can click on. Juno being one of them that you can follow. Anyway, that's. Let me just get out of this. Let me go back to the Hangout screen just to make sure nobody actually joined, because I'm not using the Google Hangout screen right now. I'm using the actual software screen. Oh, I got a viewer. Viewer, if you want to join, I'm not sure if I can let you know. Let me let me go ahead and invite some people here. I just want to introduce this. I'm going to try and invite some people. I'll figure out a way to do this. Give me a second. Okay. So I'm going to invite people. You know what? You know what I'm gonna do? Google is making it difficult for me. I'm gonna go ahead and make this public. I'm just gonna copy the Hangout screen, and I'm going to go to the event post, and I'm going to post the thing publicly. I thought I copied it. Okay, well, why can't I paste it? Okay, well, I'm going to figure this out. Give me a second. I'm going to go ahead and copy. And then I'm going to go ahead and paste. Okay, there it is. All right, so in the event page, the viewer who's watching this and found it in the event page, I'm now clicking the share button. I'm sharing this publicly to join. So hopefully you'll join. And that's as far as public is going to go. All right. Let me just take a swip. I'm going to mute my microphone for a moment and take care of a couple things, and I'll be right back. Okay, so I'm trying to play with the software. Obviously I switched to above Jupiter view, and I'm trying to figure out how to. As long as I've had this software, I've had it for years. I'm still trying to figure out how to work it properly. Um, okay, so I'm gonna leave. Oops, what did I just do? Oh man, I thought. Oh well, let me. Okay, I'll reshare it. I I accidentally clicked the unshare button somehow. Anyway, there it is again. There we go. Present to everyone. There we go. All right, so I'm just gonna hide this so I can get to the actual. All right. So I decided to try and get close to Jupiter. Obviously, I'm gonna zoom out. Very good. All right. So now I can see. You can see the path here is Juno's path. All right, but I'm trying to zoom out far enough to get the actual spacecraft, and I'm not sure if I can do it. I'm gonna hide this so that I can try again. Yeah, you can. Oh, there you go. There you go. So there's the actual. This is, by the way, this is real time. Did you notice that on the top of the screen it says real time? So what this means is that this simulation is using the data that it downloaded within seconds ago, um, to give you an idea of actually where Juno is and give you the picture, sort of a simulated picture of Jupiter and its moons and things like that. So there's Juno, okay? And that's its path, that's the orbital insertion, and that's it's on its first way out. So I'm going to zoom back in again, and you're going to see Juno disappear because it's way out there. But I'm going to zoom back in again, okay? So we're going to swing around, and what this line is, again, is Juno's path. All right. So again, the Jupiter, as you see it here, is probably a combination of an artist rendition and some real actual photos. We have some very spectacular photos of Jupiter by many of the spacecraft that have flown by, and telescope pictures. And this software uses all of the above. You know, um, the idea is that um, we have a lot of detailed photographs in the past of Jupiter. So this may be a combination of all those photographs, and some speculation on top, because there hasn't actually been specifically photographs of the northern and southern poles, and this may be somewhat simulated. But because we have such detailed images, it's hard to tell the difference between simulated and reality. So it's one of those things. Art collides with science, but it doesn't really collide. Art and science together is a beautiful thing. We need art and to help us with science. We need science for many things, but artists are able to give us pictures that we speculate. At the same time, Jupiter has been orbited by many other spacecraft, and some of these images are actually real. So this, I'm pretty sure, is a combination of real image on top of artistic image. Okay? So I don't know how else to explain it. But again, remember that this is CGI. This is, in fact, a simulation. And it is a simulation to show you where Juno, the spacecraft Juno, is actually right now. And that is, I'm zooming out, showing you right there, there's Juno. So I can actually double click on that and give you the image of the simulated image of Jupiter, Juno. Okay. Anyway, I don't know why I'm doing this hangout right now. Let me just swing back around. Let me come back out. Let me let me let me get back to where I was before, and then get back to the hangout screen and see if anybody's actually here. I just want to make sure I get to that point because I can't do two screens at the same time. I only have one monitor. This computer is capable of doing two monitors, but I only have one. Okay. All right, there it is. Okay, so now that we're back to where I was a minute ago, there it is. Okay, see if I can zoom in a little bit, give you a little bit better picture. Okay, so now I'm going to unmaximize the screen. I'm going to go to the Hangout screen. All right. So for the rest of this Hangout, I'm going to stay live for, I don't know, what is it? It's getting to the wee hours of the morning. Sunrise is coming soon. I'm going to leave this open. I'm going to mute my microphone. Occasionally, I might play with the mouse and play with the software, show you a few things. So, in other words, what I want to tell you is that as long as you see real time on top of the screen, you know that the simulation is showing what it is doing right now in actual time. So if I start playing around with it and you might see something else, you might see simulated or some other time, you'll know that it's not. So the idea is to look at the top of the screen where, where it says right now, it says real time. Know that that is actually real time. That is right now, this is a simulation of what Juno is actually doing. Again, it's not a real photograph or anything like that, or no real movies. It's a simulation of what's going on right now. That's the data that's coming down. That's the data that NASA is getting. This is where they take the data and show you in a simulation as to what's actually going on. So the distance to Jupiter is 3.85 million miles. The velocity relative to Jupiter is 6,869 miles an hour. And this is only orbit 1 of 37. Originally, they said 33, but I guess now it's 37. So 6,869 miles an hour is actually slow compared to what it was doing when it was closer. As you know, the Kepler's laws of motion, in a parabolic orbit or in a elliptical orbit, the object orbiting another object will cover the same space in the same amount of time. So when it gets close to Jupiter, I'm going to use my mouse to point. I'm hoping that you're seeing this. When it gets really close, it's moving a lot faster. Okay? But it's covering that same distance that it would as moving slower right in here, but it's covering more distance. So it's the same area that it's covering. That's why it's just physics. As you're swinging, you're going to be moving faster, but you're going in a lot closer. You're not covering as much space, but the actual space mathematically is the same as the space it's covering right now, even though it's moving slower because it's in a wider orbit. So I'm not sure if I explained that properly, but there it is. So I'm going to mute for a while, and I'll play with the software because I can't do both things at the same time. I can't watch the Google screen, which I'm watching right now, at the same time I play with the software. So I'm going to show you that now, and I'm going to mute. Okay, so I hope you realize I'm desperately trying to swing the picture around and give you a sort of a brain image of what's actually going on. Again, this is actually real time, and just wanted to break the dead silence. So I'm going to mute again. So if you watch this long enough and be patient, you will actually see this number change. The velocity 6,866 miles an hour will change. It's going to be changing at a very less and less rate. But when I first started this, yesterday or the day before, uh, we're over 10,000 miles an hour. Um, or I mean, a few days ago, we're over 10,000 miles an hour. So you could see the speed changing, and you could see the distance changing. Right now, because of its obvious swinging out, it's almost as if it's sort of in a balance. You're going to see the speed change a lot slower. But if you're patient enough, you'll see some minor changes. Again, it's a simulation with real-time data that NASA programmed into the software. And again, this software, and I encourage you to go ahead and look for it, NASA Eyes. I'm tempted to sooner or later, very soon, ending this broadcast because it's going to 5 o'clock in the morning here. So while I'm doing this, I'll give you a few more minutes on this, and I'm going to show you some of the things that it also does. I'm not going to show you nearly everything that it does because there's not enough time, but the fact that you can get it for yourself just by downloading it and installing it on your computer, you could certainly explore yourself. So I'll give it another few minutes. I'm going to mute, and I'll come back. When I come back, I'm going to shut it down and then restart it and go to some other function of the software. Okay, so some of the other functions I'm going to show you are going to be from this point. I'm not going to get out of the simulation of Juno yet, but I'm going to show you something. Let me just get back to that software. Okay, there we go. So I'm going to maximize it. So amongst the things that you can do here is, for example, I can if you notice, I can move my mouse over a particular object and it'll light up the spacecraft, Europa, one of the moons, Io, one of the moons, etc. So I can double click on one of these things and I can zoom in on that object. So Europa, as we know, has an ocean with more water than twice as much water as we have here on Earth. Io, we know, is a volcanic moon, etc. Callisto, I forget what features that I should tell you about Callisto, and I forget about Ganymede. But let's just for the fun of it, let's just go ahead and click on Io. So throughout this software, whether it be looking at Jupiter or looking at other particulars, eyes on Earth or whatever, you can double click on these things and look at various objects. So this is, again, only a simulation, but yet the this picture comes from actual photographs of other flybys. So it is a compilation. Yes, it's partially artistic. It's also partially actual photographic. I'm not going to tell you that it's strictly photographic. It's not. There's no actual detail. This kind of detail that you're seeing here is certainly not all photographic. It's certainly partially CGI. Again, this is an actual CGI software, and what they use is they use their best data, their best photographs, their best everything that they have to put into the simulation. So this particular image of Io is the best that they have put together in computer graphics. Although I'm not seeing the volcanism, which is kind of strange. I expected them to show that. But in any case, I'm just I'm doing this deliberately, and it's funny that I'm actually showing Io and Jupiter next to each other, and you can see the orbital path of Juno. So we can actually swing around if we do it right. If I can get control of it, there it is. There's Juno. One of the things that NASA needs to do is they've got this policy of planetary protection. They are actually afraid of contaminating various moons of Jupiter, especially Europa, because Europa is said to have oceans of salt water, and there may be life there. So at the end of this mission, they're going to crash this spacecraft into Jupiter to make sure that they don't accidentally contaminate one of the Jupiter's moons that may actually harbor life. But this mission, of course, has just begun. It's not even on its completed first orbit. Okay, so I'm going to mute again, and I'm going to play around a little bit more. And as soon as I'm able to, okay, mute time. Okay, so to give you a different perspective. I just wanted to show you. This is above the sun. This is sort of pretend that you're somewhere in a spaceship and you're approaching the solar system, and on your computer screen you have the ability to draw out the orbital paths of various planets of this system that you're approaching. You're an intergalactic, or you're an interstellar spacecraft. You're an interstellar traveler, and you're approaching the Earth Sol system, and you're seeing the sun here, and your computer monitor or your viewer draws out the lines of orbital paths. So you're seeing this system as it is. Is this real time? Yes, this is real time. So if you were going to pretend to be an interstellar space traveler, and you're approaching the system, and on your sophisticated viewer screen, not only do you see the planets, but you also see the traces of their orbital paths. This is what you would see. So there's Jupiter, and you're too far away right now to notice that there's actually some of our primitive spacecraft orbiting various planets. And there's Saturn, and there's also some other spacecraft out there as well. But if you were to be coming in from the top, you would see something like this. You know, again, these obviously you're not going to actually see lines, but if you were in a spacecraft, you might you might have the equipment to show you what this is showing you as their orbital paths of the various planets. So I'm going to zoom back in again. So you're an extraterrestrial interstellar space traveler looking for us because your information says that this particular solar system has a semi-intelligent life form on one of the planets in this entire system, and that is Earth. And so you came in to investigate. So let's go ahead and click on this. Okay, so obviously we have enormous data on our own planet. We have hundreds, maybe even thousands of satellites orbiting Earth, weather satellites, etc. So this is, I'm showing you this because I'm giving you a comparison to the Io image that I showed you before. It looks just as fake, right? I hate to use that word fake, but it looks just as fake. The idea is that this is actually still CGI, but again, we're using the images that we already have and also computer graphics. So this is I'm trying to describe this software in such a way that I'm trying to explain how the art and the science work together. This is artwork because this is only a simulation. But this, in fact, is real time. Okay, so real time means that this is, you know, we're following Juno, the spacecraft. So the real time being that this is what Juno was seeing, or, you know, of course, this is just zoomed in. But and for all you flat earthers out there, yes, the Earth is actually fucking round. Yeah, you can spin it around all you want. Anyway, I'm going to mute again, and as soon as I unmaximize the screen, do I have people here? Oh, I'm sorry. Do I actually have people here? Nobody said anything.
Hey, what's up, Patrick?
Hey, what's up, Patrick?
I'm sitting there babbling to myself, and I didn't realize I had people here.
How you doing, Patrick? I haven't seen you in a while.
Yeah. Let me just readjust my brain here. Um, okay. So Bulldog. Bulldog actually joined the video call. Okay.
Hey Patrick, did you fucking block me?
Hang on a second. I need to readjust things here. I didn't realize I had people here. I was babbling along to myself, and I was just basically making a YouTube video because I'm following Juno, and I was going to include this on my YouTube. I did share it with Google, and I was kind of hoping for some people to join. I
Yeah, well
actually
we're
didn't
doing
expect
now, so we're
anybody, and
gonna
I'm
follow
very
our
happy that everybody here joined. So give me a minute, and I need to readjust some things.
Alright, time's ticking. Right?
Hey, Bulldog outbound. Brett's still online. Do you want me to send him? Can I send him the link too?
Yeah, you can send the link to anyone you like.
Well, why don't you ask Patrick?
No,
Hey,
why?
Patrick.
Why?
Well,
Okay.
because it's Patrick's hangout.
Yeah, I got you. Sorry.
Yeah, it's all good.
Hey, Patrick, if you can hear me, would it be okay to invite this buddy named Brett I know?
Hang on, who's talking?
Me, Malik.
Like, you want to invite one of your friends?
Yeah, his name's Brett. He's really cool. His name
Oh, okay, yeah,
Brett
sure, all
Moore.
right, yeah, sure.
All right.
Hang on, I'm still trying. I'm trying to figure something out here. I'm sorry.
Okay. Oh, here he is. Never mind.
Oh, hey, Brett, I know you. How you
What's
doing,
up,
man?
guy? Doing pretty good, man. How about you? How was Eraserhead?
We didn't end up watching that. We ended up watching Project X.
Project
Oh,
X.
I got that movie. That's funny as hell.
Yeah, that's a
With
really
with
funny movie.
with the four with the three guys doing a house party.
Yeah.
Yeah, I got the unrated version.
Oh, cool, dude. That's awesome.
I
Yeah,
heard
it
about
was
it. I
a
never
fucking
saw it.
funny movie.
I heard it was kind of based on a true story because they said that the four kids that did that got charged because they decided to riot.
Oh, I don't think so. I think it's actually, I don't think so. But you know the guy Dax, the cameraman?
Yeah.
He's been on YouTube since like 2006, doing like really weird vlogs where he basically does this character of this like very socially awkward, really weird person.
Oh,
And
okay.
yeah, so
If you know his channel,
so he was a YouTuber before he was like started getting roles in all these comedy films.
okay.
Yeah,
Is his channel still up?
yeah. If you ever look it up, it's called Dax Flame. Yeah, and
Yeah.
I watched him way back in the day too.
Send me
That
the link to
wasn't
his
very
channel.
nice, Patrick.
Oh yeah, I'll send a link
I
to him.
want to talk to him. Yeah, I want to talk to him.
You gotta stop kicking me out of your hangouts, Patrick.
Where's Patrick? Where did Patrick go?
He's gone.
He left his own hangout.
No, he kicked me and I kicked him. I wasn't
So
even
you,
saying anything and he kicked me anyway.
so what? So somehow you got control of you got control of this hangout too.
Yep.
Damn, you must have some kind of hack powers or something. Damn, that's twice now. You kicked Luke out of his hangout and then kicked Patrick out. Oh well.
What's going on, guys? What are we talking about?
We're talking about science.
What kind of science?
I think Pat was talking about the Jupiter mission.
Juno. Okay, cool.
No, did oh,
It's
it was
Juno.
called Juno.
Juno's the moon for Jupiter, I think.
Oh, okay.
I've seen the movie Juno with Ellen Page, which I thought was
Yeah,
very
yeah,
weird.
I like that one. I
Which
really
is
like
very,
Ellen Page.
which is very weird. Yeah, too bad she's a lesbian.
What do you mean, too bad? Oh, yeah, I get you. She is a
Yeah,
cute girl.
for me, you know.
Yeah,
Yeah,
yeah, but
I try to give that. But she likes women. Damn.
yeah, you know, she's got a really good show on Vice. It's called Gaycation. It's really, really fucking
Oh,
good.
okay.
It's about like gay people like everywhere, like in different countries, like how homophobia is like all over the world. It's different, depending on where you go.
Yeah, some countries don't give a fuck, and some countries are like, you're gonna die because you're gay.
Yeah, what's really interesting is like Japan isn't a
Oh,
very religious country, but it's still like there's still a lot of stigma against gay people. So
That's
it's interesting.
crazy.
It's interesting how it's like it's not always based off religion. It's like just kind of like against the men not being masculine enough.
Right.
That's a big part of it. Is just like
It's
men
more of an
aren't.
honor thing.
Yeah, exactly. That's how it is over like in Japan and like a lot of Asian countries.
That's crazy.
Why is it that people are so quick to threaten the FBI? I see that a lot on G+.
I don't know what that's about.
Hey, I can't find you on Hangouts, Malik. I'm trying to.
oh, I'm
Oh,
in.
actually, because there's no side chat in here for me to send you a private message.
Oh, okay. Yeah,
Have I been mispronouncing your name? Is it Malik or Malik?
it's Malik. No,
Malik.
Malik.
I got you.
Yeah,
yeah.
sorry.
If you have the Google Chrome app, that's where you can chat with me. That's why I've been chatting with you because I sent you the link in the messages in it. You know.
Oh, okay. Through Chrome or through Hangouts?
y- y- y-
Oh,
y- You have to hang out back chat. So that's what I call it. Oh, that's
oh,
okay.
through this little thing.
Yeah.
I was posted right here.
Okay. Yeah.
Yeah, right there. That's his user. That's his channel. Yeah, some
How's
of
it
them are pretty
going?
funny, but a lot of them are just painfully awkward.
Okay.
How's it going, Bulldog? I haven't heard your voice since I got in here.
Oh, I'm here. I'm just fucking. I'm just wondering, did Patrick go violent again on Outbound?
Yeah. Yeah, he did.
Oh, Brett. So where'd you post it? I don't see it yet.
I was very quiet too. I was being very respectful.